Very good morning to all of you. It's so good to see that so many of you have joined the classes. So yeah, let's get back straight to the point here. Good morning all of you, each and every one of you. Let's just get to the point here now. So in the previous two videos, we have already seen, learned something about matrices. What are matrices? How do they actually work? What are the different types of matrices? We've already seen all those different types of matrices and all. So now let's move on further. Let's move on further to the operations of matrices, like is addition, can we add two matrices? Can we subtract two matrices? Can we multiply matrices? Can we divide matrices? So many questions that we have to answer now. So today in this session, we will try to learn as much as possible on the algebra or the operations of matrices. Like, we will try to answer all the questions, whether can we add, multiply, divide, or subtract matrices. So addition we can, subtraction also we can. That means we can add and subtract matrices also, two matrices or three matrices and so on. So the first question is already answered, that is yes, we can add matrices, we can add or subtract matrices, but is there some conditions, are there some conditions on which addition and subtraction depends on? Yes, there are some conditions. Let's see what are those conditions. Addition of matrices, let A and B, I'll keep it very simple, but this is how the definition goes, so it's good to write down the things technically also. Okay, so I'll just give you the definition. Let A and B be two comparable matrices each of order m by n. Comparable matrices, last class we have already discussed. I believe you have the notes. If not, you can go and check out the previous videos. Then their sum A plus B is a matrix. Then their sum A plus B is a matrix of the same order, of order m by n, obtained by adding the corresponding elements, obtained by adding the corresponding elements of A and B. Chubamanla, Nanshubanla, Priyanshu, Lalwinla, Kinkali, Chubamanla, Nasala. Okay, there are some names which Imtiala, Intisana, Chompongsan, Kilang, Rongsan, Aman, I guess. Yeah, a very good morning to each and every one of you. And there's one name like Afterlife. Yeah, I keep on forgetting this particular student. But anyway, a very good morning to each and every one of you. So this is how the definition goes. But forget about the definitions. That is just the formality. Of course, you can write a note. I'll tell you all about that. For two matrices A and B, for two matrices A and B, the sum, this is important, the sum A plus B exists only when A and B are comparable. Exists only when A and B are comparable. All right. Okay, so that's what it's all about. Forget this. Now, let's get back to the point, that is addition of matrices. How can we add matrices? Can we add matrices? As we have seen, yes. When, as we have just seen here, two matrices can be added, or it goes the same for subtraction also. Okay, the same goes for subtraction also. So two matrices can be added or subtracted if they are comparable. Comparable means what? What was that? Last class we have seen, if they are the same order. So if we have, so yes, we can add or subtract matrices, provided that those two matrices should be of the same order. And how do we add matrices? The resultant matrix that we get after adding or subtracting is by adding and subtracting the corresponding elements. That's why they have to be of the same order. Example. Like for example, if we have a matrix 1, 2, 3, 4 and matrix B 5, 6, 2, 1. So now the question is, yes, can we add matrices A plus B? I'll do simultaneously for subtraction also, because almost all the properties are same for subtraction also. So it's subtraction as well as addition only. Okay, same thing. Just like only when we go for multiplication, yeah, that time, yes, conditions are going to be different if it is possible. So can we add matrices? Are they defined? Yes. These two matrices can be added. Why? Because they are of the same order, 2 by 2 and 2 by 2. So in that case, how do we? Very simple. Let's keep it very simple. Forget about the textbook definitions and all the other stuffs. We can do that later on, the theory stuffs and all those. Now let's first learn how to do the basic things. So A plus B, can we add? Yes, definitely we can add. What will be the order of the new matrix that you get after adding or subtracting the matrices? It's very simple. Since the condition is that they should be of the same order, so that their corresponding elements can add or subtract, the order of the resultant matrix also remains the same. 2 by 2 only, 3 by 3, 4 by 4. Then how do we add? We add the corresponding elements. That is 1 with 5, 1 plus 5. Here corresponding elements, 2 plus 6. That's why they have to be like comparable, no? Then only we will have the corresponding elements which we will add. So that's like 6, 8, 5, 5. Simple as that. So that's how we will be just adding or subtracting matrices. Similarly, the same thing goes for subtraction also. The same thing goes for subtraction. That's why I'll just give you the subtraction also. We'll learn the negative of a matrix also, but just how do we just subtract also directly. Subtraction also will be same, that is 1 minus 5. Minus 4, 2 minus 6, minus 4, 3 minus 2, 1, 4 minus 1, 3. So that's the basically the simplest stuff, no? Addition and subtraction. Yeah, definition wise, theory wise, there are many properties and all. We will be doing all those properties also. Alright, so basically that's what we have with addition and subtraction of matrices. Now some properties regarding this, especially let's start with addition first. Now, I hope that's clear, no? Addition of matrices, nothing much. Okay, just how do we add matrices? Very simple. We just add, provided the condition is that the two matrices should be comparable. That's very simple. Some properties. We are not going to be discussing this in details, but I'll just give you the properties so that you will not think that I did not give you an all. No, so just for that. The first property is matrix addition. Matrix addition is commutative. Matrix addition is commutative. Commutative means A plus B is equal to B plus A. A plus B is equal to B plus A. Second property, matrix addition is associative. Matrix addition is associative. Associative, of course, that is like A plus B plus C is equal to A plus B plus C. Something like this. Associative property. Third property, I'll just give you. Zero means, if you remember, no, zero matrix. A plus 0 is equal to A. These are just some formal, normal properties. Okay, so these are some basic properties only. Next up, we have like quickly like a negative of a matrix. So let's not. But before that, before the negative of a matrix, yeah, better we write down negative of a matrix. Negative of a matrix. Let A be a matrix Aij of the order m by n. Then the negative of a matrix, and the negative of a matrix minus A, that would be minus Aij of the order m by n. Obtained by replacing each element, of A with its corresponding additive inverse, So negative of a matrix is nothing but minus of A. If A is a matrix, then minus of A is the negative of a matrix. What do we mean by that? That would mean that each element of the matrix A will be replaced by its additive inverse. That's what we have. That's what we say. That's what is called a negative of a matrix. Concept is very simple. Negative of a matrix simply means additive inverse. That means sometimes negative of a matrix is also known as the additive inverse of a matrix A. I'll give you one example. That is, A is, let's say, 1 minus 1, 2, 3, 1, 0. So in that case, what will be the negative of a matrix? Negative of a matrix will be just replace each of these elements by the additive inverse. Very simple. Minus 1, plus 1, minus 2, minus 3, minus 1, 0. That's what it means. Minus of A. Now, so let's not confuse ourselves with that. Alright, so next, another important topic. Important important in the sense like these are new things, so it's good if we know. Scalar multiplication. So as I mentioned, same thing goes for subtraction of matrices also. Okay, for addition also, same properties for subtraction also. So basically, it's of course for subtraction regarding zero matrices and all would be same. I mean the operations and all. How do we add and how do we subtract matrices? It's basically about subtraction only. They should be of the same order, so we can add the corresponding elements. Properties, of course, will be slightly different. Commutative, associative. Now we cannot say about that. So that we'll have to do some other time. And we'll be now focusing strictly on the syllabus part only. Okay, so here, as I mentioned earlier, class 12 matrices, of course, it has its wide varied applications, but in class 12 we are here just to learn the operations of matrices. How do we do matrices? The basics of matrices. You know, just what are the terms associated with matrices, properties, and what happens and what doesn't happen, and all you will learn in your higher classes. All right, that's from after class 12. Go for engineering or medical, engineering or basic science and all courses and all. That time you will be learning. It's a huge topic. You'll get to know very soon. It's a huge topic. We have a different paper on matrices. Okay. Here, just the basics. How do we add, subtract? So I'll not confuse you with too many properties and all. No. Let's get straight to the point. How do we do this? How do we add? How do we multiply? How do we subtract? Only those I want to be discussing about those only. Okay, in detail, yeah, some other classes. Alright. Now scalar multiplication, this is important. Like how do we multiply a matrix by a scalar? What happens? Let A be a given matrix. Let A be a given matrix and let's say K be a number. Number means a scalar. And let K be a number. Then the matrix obtained by multiplying, then the matrix obtained by multiplying each element of A by the scalar K is called the scalar multi multiple of A by K is called the scalar multiple of A by K to be denoted by K into A. That's what it means. I'll tell you about that. As I said, I'll give you an example with that you will easily understand. But definition wise, this is what we have. So that means if K times of A will also represent K into Aij M by N. So the order doesn't get affected, yes, but when you multiply a matrix with a scalar, then what happens is the resultant matrix, each and every element will get multiplied by the scalar or that number. So that's what we will be having. Okay. Example. Example like, let's say we have a matrix A. Let's say we have a matrix 5, 4, minus 2, 3, 1, 3. Then 3A. What will be 3A? Then that means I'm multiplying the matrix by the scalar 3. So simply each and every element of the matrix will get multiplied by 3. I hope you can get the point here. 3 3s are 9, 3 1s are 3, 3 3s are 9. That's what it means there. So how do we multiply a matrix by a scalar? What happens? This is what happens. Each and every element also of the matrix also gets multiplied by the scalar. Another example, let's say minus 2A. And in that case, what will happen? Each and every element will get multiplied by minus 2. So minus 2, 5, minus 10, minus 8, 2 to 4, huh? 2 to 4, yeah. Minus 6, minus 2, again minus 6. Yeah. Got it? Alright. So these are the two basic operations on matrices, as I said, subtraction as well as addition. Of course, for subtraction also you can write something, maybe if you wish. Subtraction of matrices. Subtraction of matrices. But yeah, of course, calculation, as I said, will be simple. We'll be just subtracting. Nah. If A and B are two matrices, if A and B are two matrices, not two, just two matrices, two comparable matrices, two comparable matrices are two comparable matrices, then A minus B is also defined as A plus of minus B. Just a small note. Alright, chalo. But don't confuse yourself. Let me just summarize that again. Addition, subtraction, no complication. Addition, subtraction, simple. They should be of the same order so that we can add or subtract the corresponding elements. How do you multiply a matrix with a scalar? Each and every element of the matrix gets multiplied with the scalar. Bus. Alright, let's try some examples. Alright, let's try some examples. Let's say example 1. If we have two matrices A, let's say 3, 5, 7 minus 9, 3, 5, 7 minus 9, and we have a matrix B. Six minus 4, 2, 3. 6 minus 4, 2, 3. Then find for A minus 3B. So let's find out for A minus 3B. Directly, there are some properties where we go for this. Actually, it should be like something like 4A plus of minus 3B. If you just want to write in, the basic detailed course, it doesn't matter. We will just add and subtract. It really doesn't matter. But okay, chalo. First one at this, I'll tell you how it is. That's the way we write the plus of minus 3B. Doesn't matter, but some are very specific about all this. So 4 into A, I'll just do it. 4 into A, 4 3s are 12, 4 5s are 20, 4 7s are 28, 4 9s are 36. Plus minus 3B, minus 3, 6, minus 18, minus 3, minus 4, plus 12, minus 3, 2, minus 6, minus 3, 3, minus 9. Actually, we can just do for subtraction also, but as I say, some are very specific about all this. But that's why. Otherwise, it's fine only. 20 plus 12, 32. 28 minus 6, 22. Minus 36, minus 9. So minus 6, 32, 22, minus 45. That's how we will be doing. So yeah, of course it's good if we know everything in detail, how it works and all. Another example. if we have A, remember this? Last class I told you what it represents. Yeah, so last class, you remember last class I told you what it means, isn't it? So what would be A plus B? Dig. What do you mean by this dig? Dragon. Diagonal elements, isn't it? Diagonal elements of order what? 1, 2, 3 of order 3 by 3. So this is, sorry, 3, 0, 0, 0, minus 5, 0, 0, 0, 7 plus minus 1, 0, 0, 0, 2, 0, 0, 0, 4. So adding the corresponding elements, we'll have 3 minus 1, 2, 0, 0. You'll also be, the result also again should be a diagonal matrix. No? So 0 minus 5 plus 2 minus 3, 0, 0, 0, 7 plus 4, 11. So this also again can be written as diagonal element, diagonal matrix 2 minus 3, 11. Alright, now the other one, that is A minus B. A minus B. So this will be better written as A plus minus B. We will stick to the detailed, with big problems we'll solve later on. Minus and all, but yes, let's start properly. Yes, so plus A plus minus B, that means minus of B. So that's when you minus plus, minus, minus. Now minus of B. So now we just add 3 plus 1, 4, 0, 0, 0, minus 5, minus 2, minus 7, 0, 0, 0, 7, minus 4, 3. So A minus B, 4 minus 7, 3. And finally 2A plus 3B. 2A plus 3B. So 2A, this is A, 2 3s are 6, 0, 0, 0, minus 10, 0, 0, 0, 2 7s are 14. Plus 3 times of B. So I'll just rewrite this once because I just want to write down the value of B. B was minus 1, 2, 4. Minus 1, 2, 4. So 3 times of B will be minus 3, 0, 0, 0, 3 2s are 6, 0, 0, 0, 3 4s are 12. Yeah, so just add this 3, 0, 0, 0, minus 10, that's minus 4, 0, 0, 0, 28, 26. Done? Alright. Let's another example. Find matrix X. Find matrix X. If X plus this matrix 4, 6, minus 3, 7 is equal to the other matrix 3 minus 6, 5, 3 minus 6, 5 minus 8. So as I mentioned, we are trying to do things very technically here, So later on, of course, with bigger problems, we will be just doing it directly, just adding, subtracting. But technically, yeah, it's good. As I mentioned, some are very specific. In one way, it's very true also. So you have to be like, just know the basic stuff. So x plus, instead of the matrix, I'll just represent the matrix A and B. So to find x, this will be B minus A. We just remove that. Actually, we can't do that. Actually, we can't do that. Actually, what we do is, by adding negative matrix on both sides. So x plus A minus A, B plus of minus A. That's what happens. So A done, same matrix. So we have the 0 matrix. So x is equal to what? B plus of the negative of the matrix A. That's what we have. Okay. It's algebra only, so you can do it also. No problem with that. So x will be equal to B matrix 3 minus 6, 5 minus 8 plus negative of the matrix A. Minus 4, minus 6, 3, minus 7. So our matrix X would be 3 minus 4, minus 1, minus 6, minus 12. 5 plus 3, 8, minus 8, minus 7, minus 15. So this is our matrix X. Of course, for algebra, we can just go directly, no problem. Like, for example, that's not a big deal. It's something like this, so it's like x of b minus a, so that's like b plus of minus a and all. No problem, we can do that also. We can do that also, or we can do it the other way that I just showed you. It's all the same. It's all the same. Addition only, addition, subtraction only. Things become complicated when we start doing matrices, multiplications, inverse, adjoint, transpose. There are properties which we have to follow. Addition and subtraction, not a big issue there. Okay? Alright, now let's go to the next topic. Multiplication of matrices. Is multiplication of matrices possible? Yes, it is possible, but with some certain conditions. What are those conditions? Let's have a look about that. Condition is simply this: for two given matrices, that means we simply just cannot multiply two matrices, just any two matrices we cannot multiply. Okay, there are some conditions. The condition is this: for two given matrices A and B, we say that the product AB exists. We say that the product AB exists only when the number of columns in A is equal to the number of rows in B. Is equal to the number of rows in B. That is, when AB exists, we say that A is conformable. C-O-N-F-O-R, conformable. We say that A is conformable. C-O-N-F-O-R-M-A-B-L-E, conformable to B for multiplication. Conformable. That's how we use technically. Conformable. Okay. So yeah, matrix multiplication is slightly complicated. Not difficult, of course, yes, but there is a condition that, yes, that means we can multiply two matrices AB, that is also AB. BA, we cannot say again. So for two given matrices A and B, we can say that the product AB exists only when, remember, the number of columns in A. Remember, whenever I give you example, the problem always becomes easier. But definition-wise, okay, you might be confused always, like, okay, what is he really trying to tell you? But you know that with examples, I will make the problems simple, easier for you. So wait for the example. But yeah, technically, yes, this is the definition, that is, which we are supposed to know, isn't it? Technically, also we need to know things. So when the number of columns in A, when the number of columns in the first matrix is equal to the number of columns in the second matrix, then we can multiply the first matrix with the second matrix. Something like that. If you are supposed to multiply two matrices, first, second matrices, then the number of columns in the first matrix should be equal to the number of rows in the second matrix. Columns, rows. First, second. Columns, rows. Number of columns in the first matrix should be equal to number of rows in the second matrix. Then only we can go for matrix multiplication. Otherwise, not. And if they are possible for multiplication, if they exist, that means if AB exists, then we say that A is conformable to B. That's what we say technically. Then in that case, what will be the order of the new matrix? Because we have seen for addition and subtraction, since we demand that they should be of the same order, comparable matrices, the order of the matrix doesn't change for addition and subtraction. For multiplication, it will change. How? We can note down this, I'll give you. Something like a note. If, I'll tell you how to remember, but if A is an M by N matrix, if A is an M by N matrix and B is N by P matrix, M by P matrix, then AB of course will exist, then AB exists, and it is an what matrix? What will be the order of the matrix? It's very simple, you see. Listen. A, its order is M by N. Then we are trying for A cross B. I mean, we are trying to multiply A to B. B matrix is M by B. We're trying to, no, we are saying that AB exists. That means first matrix, A to B. That means A is conformable to B for multiplication. Why? Very simple, because the number of columns in the first matrix is equal to the number of rows in the second matrix, isn't it? The number of columns in the first matrix, listen carefully, now the number of columns in the first matrix is equal to what? The number of rows in the second matrix. So what will be the order? I'll give you a hint on how to just remember that. What we are supposed to do is, see, when we are supposed to multiply A and B, after checking that they are conformable, the order of the new matrix will be N, it's something like we're just removing it. So the order of the new matrix will be M by B. That's what basically the condition is also all about. Alright, now in that case, will BA be possible? Let's check. What is B? N by P. A is M by N. We can see that this number of columns in the first matrix is not equal to the number of rows in the second matrix. That means this is B is not conformable to A for matrix multiplication. That means BA does not exist. So this is one condition which is normally asked. Okay, this is a situation which is normally asked. That is like for any two matrices A and B. Number one, for any two matrices A and B, AB may exist, as we have just seen just now. AB may exist and BA may not exist. That means even if we can multiply A to B, that is, even if A is conformable to B for multiplication, it is not necessary that B also will be conformable to A for multiplication. That means if AB exists, doesn't necessarily mean that BA will also exist. We have just seen that example just recently. And likewise, if BA might exist, AB might not exist. So there are many all those conditions and all. Okay. So that is what is matrix multiplication. I'll give you an example, and only in the next session we will be doing matrix multiplication in detail. But now I'll just give you an example for you to digest. Let's see what is really meant by matrix multiplication. Let's see if matrix A, how do we multiply? Of course, how do we multiply a given matrix again? So conditions we have seen. How do we multiply a given matrix? Now, when can we multiply? Now, how do we multiply? Let's see. When can we multiply two matrices? We have already seen the condition. Now the question is, how shall we multiply matrices? That I'll show you now with an example. Definition wise, you will not understand. We multiply the corresponding, go for the sum of the corresponding elements of the ith row with the jth column, and no, forget about that. I'll give you an example. We will simplify with that. 2, 3, 1. But for that, you will have to follow some basic things. And the matrix B, minus 1, 3, 2, 1. So this is our matrix. So, is AB possible? The product AB possible or not? Let's go for it first, step by step. Listen to me very carefully, okay? Let's check. AB. A, what is the order? 1, 2, 3. 3 rows, 2 columns. And B, what is the order? 2 rows, 2 columns. Now you can see that the number of columns is equal to the number of rows. So definitely AB, of course, will exist. So what will be the order of our new matrix AB? It will be order 3 by 2. You have to sort these things out, okay, when you proceed for multiplication. Maybe in the rough also you can do that, because this will exactly help you. Trust me, this will help you avoid any confusion with matrix multiplication. Now we know the order of the matrix 3 by 2. I will prepare a rough matrix. 3 by 2 means we will have 3 rows and 2 columns. So it's 1, 1, 1, 2, 2, 1, 2, 2, 3, 1, 3, 2. This is how our matrix should look like. A matrix of order 3 by 2. So this is done. So now I know. So these are some basic steps which you need to follow. That is, before we really go for matrix multiplication, check whether they are conformable or not. Yes, after that, decide the order. Once you decide the order of the matrix, Yes, make a sample in the beginning part. Later on, maybe you can just skip all these steps, but yes, prepare a sample matrix on how your matrix should be looking like. So it's like going to be like 3 by 2. After that, you follow this basic stuff. Multiplication, trust me, it's going to be very, very easy. Now, solution will be, the matrix AB will be, now you see, first element, that is first row A11, that means first row, first column. First row, first column, that means I will be multiplying and adding the corresponding elements of the first row with the first column. I will be multiplying and adding the corresponding elements of the first row and the first with the first column, A11. That will help you. That is first row, first column, A11. That's what it means. A11, first row, first column. Corresponding elements you multiply and add. So first row, first column. So it's going to be, I'll just show you. First row, first column, got it now? So it's like 2 into minus 1 plus minus 1 into 2. Ith row, jth column. That's what we're supposed to do. Corresponding elements. And we will add them. First row, first column is so corresponding elements. 2 into minus 1, minus 1 into 2. Similarly, the next one, A21. This one, I'll go for this. A21. That is second row. A21, second row, first column. Again, corresponding elements and rows. Let's multiply. 3 into minus 1 plus 4 into 2. Similarly, 3-1, third row, first column. That will help you avoid confusion, that's what I mean. Okay, so we will be very specific with that. No? So the systematic third row, first column. There are different ways, of course. I'll definitely try to bring out another videos on multiplication itself. Okay, so that will also help you. First one is done. Next, I'll go to first row, second column. That is A12. That is now again first row, second column. First row, second column. 2 into 3 plus minus 1 into 1. Next, second row, second column. 3 into 3 plus 4 into 1. Next, third row, second column. 1 into 3 plus 5 into 1. This is done. I don't need this anymore now. First, you just have to now multiply and add, add only. So that's basically how you multiply two matrices, provided that they are conformable to each other. So yeah, definitely it's not going to be that simple like addition and subtraction. You will need a lot of practice here. Okay, you will need a lot of practice here. So practice would hold the key to this. So yeah. I'll leave you here for today with the matrix multiplication. So I'll just leave you with a comma here, no full stop. Full stop in the second session tomorrow. Okay, so I'll leave you with a comma here with matrix multiplication so that you would be eagerly anticipating for the next video where we will do matrix multiplication fully, completely, and their properties also. But properties, as I say, not much in detail, but yeah, at least I'll give you some properties also. All right, so I guess that's it. So yeah, don't be confused. As I say always, in the beginning, please do remember things are always very difficult. No matter what you do in life, not only studies, everything is confusing and difficult. Many give up in that process, in the first phase. Don't do that in the beginning. Things might look very confusing and very tough and all. Have patience. You cannot expect for miracles just overnight. Okay, that is something which is really not very logical at all. But be patient, be consistent, be determined, work continuously on your problem. Maybe just work on it, think of finding solutions. Maybe in a month or two, especially in mathematics, slowly, you will begin to realize that okay, you are getting better. But just in a week, don't expect that you will get better. No, that's not possible. Okay, it takes years and years of hard work. So you just cannot expect to learn overnight, or you just cannot say that okay, 2 weeks I worked hard, I still cannot learn anything. No, that's not logical. Okay, be logical, be practical. So yes, definitely things will be a bit confusing. You have the calculus portion also coming up. Definitely things are going to get confusing, but please don't be confused. Be determined, consistent. Be consistent also. Okay, so fine then. I'll see you in the next session. I mean, that's like tomorrow or whenever it is. The next session with more on matrix multiplication. All right then. Have a good day, all of you. Please stay safe. And please do study at home. Okay, do not waste time. Class 12 students especially, very, very important. No, there is no division of matrices. We'll be stopping at multiplication of matrices only here. All right then, see you. Bye bye, take care.